Welcome. This is Mr. Perry with part 3 and the concluding segment of Ms. V's presentation of Introduction to Science and the Scientific Method. In earlier segments, we explored observation and how our senses give us information about the world. We draw conclusions about those observations based on what we think we saw, smelled, felt, heard, or tasted. Those conclusions are called inferences, and we make predictions based on those inferences. Now, scientists are people who collect and organize information, looking at patterns and connections between events, proposing explanations that can be tested by examining evidence. Now, those tests include quantitative and qualitative data. Quantitative data uses numbers. 50 people got sick, or the tree grew 10.5 feet. Qualitative data uses the senses. The flowers smelled sweet. The soup was purple. Once we examine our data, we can make an educated guess about what we think is going on, which is called an hypothesis. Now, the scientific method helps us to test our hypothesis through experiment and helps us create a theory that is a statement of what we think is true. The steps in the scientific method include observation, or asking a question, do research to form a hypothesis, design a controlled experiment, record qualitative and quantitative results. And that's where we left off in our last segment in this series. We're going to move now, turn the page, and look at analyzing results. We lead with some questions. Why is it important to have a large sample size in any experiment? It is important to test a large sample in order to get a true picture of the results of the experiment. If the sample size is too small, an inaccurate conclusion may be reached. Results obtained by testing a large number of individuals would be much more accurate than if only a few individuals had been tested. That is, we get a more accurate result when we look at 100 things rather than just 10 things. Why is it important to experiment many times? Experiments should be repeated to see if the same results are obtained each time. This gives validity or accuracy and more truth to the test results. And what is the importance of the control? Without the control, there would be no basis for comparison, and you would not know how the experiment factor affected the results. That is, if I change everything in an experiment and my result is different, how do I know which thing caused the change? Well, how is a theory different than an hypothesis? An hypothesis is an educated guess that is testable through observations and experimentation. A theory, on the other hand, is a broad statement of what is believed to be true based on many experiments and considerable amounts of data. Theories can change if they are later disproven. So, once again, an hypothesis is an educated guess, while a theory is believed to be true based on tests. So here are some open-ended questions that you should make an attempt to answer. Why is it so important that a scientist accurately describes the procedure used in the experiment? What is the difference between the independent and the dependent variables in an experiment? And in a controlled experiment, why must all of the variables, except one, be kept constant throughout the experiment? So there you have it. Introduction to Science and the Scientific Method. This is information that you can use in your scientific studies as long as you're in school, as well as in all of your everyday experiences. So you have it there. Plenty of information. Let's hit it and quit it. Let's go.